Good evening, my name is Haneen and I am presenting our report on microwave photonic radars. This work was prepared by me and my team Ashraqat, Musa and Lara. Starting with the introduction, microwave photonics is a field that merges optical technologies with radar engineering. The concept is simple. We convert microwave signals into optical signals to be processed using lasers and fiber optics. Our primary objective is to use the massive speed and bandwidth of light to achieve extreme precision that traditional electronics cannot provide.
Hi, my name is ashraqat. Traditional radars face electronic bottlenecks in bandwidth and speed. Photonics provides a solution by using ultra-low loss optics, which are immune to electromagnetic interference. We use microwave photonic oscillators (OEOs) to generate ultra-pure reference signals. These signals provide high-frequency stability and are immune to Q vector degradation.
As shown in the table, photonics outperforms electronics by increasing bandwidth from 4 to 40 GHz. We also replace heavy cables with lightweight optical fibers, which improves imaging resolution from 15 cm to just 1.3 cm. To maintain this precision, we use optical beamforming (OBFN). This technology solves the beam sequence problem, ensuring a stable and accurate radar direction across all frequencies. This makes it the perfect solution for UAV and stealth aircraft.
Looking at the future, the roadmap focuses on full integral by using formatting integrated circuits PLC. We can fit another radar on a signal chip. This also for mass deployment in autonomous visual and UAVs. In conclusion, microwave photons is the essentially braided to aggregate high resolution and wideband radar. It offers superior performance in size and immunity to interface. This chip skill development is the finally front for modern radar technologies. Thank you for listening.